Welcome to Genius Panda Virtual Labs, where students and teachers access the virtual laboratory simulations for various science subjects.
Hello everyone. Today we are discussing chemical equations. That is unit number 6 of Senior 2 according to Rwanda Education Board curriculum. And the simulation we will analyze today is balancing chemical equations. Remember, you find this at www.panda.xyz. Here we have the objective of our lesson. At the end of this lesson, we should be able to balance chemical equations using the lab simulation. And the key concepts. What is a reaction? What is an equation? What are the reactants and products? A chemical reaction is a process through which reactants or some substances, the initial substances, they are transformed into products. The initial substances, we call them reactants, and the final products, the final substances, we call them products. And those are the new substances which are formed through this chemical reaction, which is a chemical change. And an equation is a symbolic representation of a chemical reaction. The equation is a symbolic representation of a chemical reaction. Let's take examples. Let's say that hydrogen is reacting with oxygen to produce water. That is a chemical reaction. And how can we represent that process? We can use the symbols. Let's say we have hydrogen, which is a gas, and we add oxygen, which is also a gas, to produce water. And here we use a half. So this representation is the representation we have here is the chemical equation, and the process which is taking place, the chemical change which is taking place, is a chemical process or a chemical reaction. The substances we start with, they are called reactants, and the final substances that we produce, they are called products. Reactants are always on the left hand side and products on the right hand side. Balancing chemical equations. What is the purpose of balancing chemical equations? Remember the law of conservation of matter. It says that matter is never created, nor destroyed. So you can't explain if your equation is not balanced, you can't explain where some of the substances have gone or where some of the substances came from. So you should always have the left-hand side substances which are equal in amount and mass to the right-hand side substances. Okay? So it should be an equation. Remember, even in mathematics, we call an equation an expression in which both sides are equal. A mathematical expression where both sides are equal, we can call it an equation. And it is the same in chemistry. A chemical equation should always be balanced. Otherwise, it's not really a chemical equation. So let's move right away to the simulation and see how we can use it to balance chemical equations. Here we have the default appearance of our simulation. The simulation is called balancing chemical equations. And this is the default appearance. When you open the simulation, the first thing you see is this one. And here you see we have ammonia can balance this process or this equation involved when we produce ammonia from its constituent elements. We can also balance the equation when water decomposes to give its constituent elements. And we can also balance the equation when we combust methane to produce carbon dioxide and water. Here we can hide the box and we get the name. These are reactants. And here we can hide the box and we get the name. These are products. And here we have the tools we can use. These tools right now we have no tools, and when we'll be balancing, I will use both tools to let you see what it's all about. Now let's start with ammonia. We have 0 moles of nitrogen, 0 moles of hydrogen, and 0 moles of ammonia. Like this, there is no reaction because we don't have reactants, because here it is 0 and 0, so we don't have reactants. So to get this one, let's say the reaction is taking place, but it's not balanced, and our purpose is to get the equation balanced. On this side, the right-hand side, we have 3 hydrogen atoms. And here we have 2 hydrogen atoms. They are not equal in number. So we have to find a way of making them equal. Here we have 1 nitrogen, and on the left-hand side, the reactants, we have 2 nitrogen. And let's say this is 1. So we have 1 mole, which contains 2 nitrogen. And here we have 1, and here we have 1, at least for the reaction to take place. What you can see here is that we have 2 nitrogen, as I said, and here we have only 1. And if we want the nitrogen atoms to be equal in number, then we increase. Just you click on this upward arrow. Like this, we have 2 nitrogen atoms and 2 nitrogen atoms on both sides. So for the nitrogen atoms, it's balanced. Now, what about the hydrogen atoms? Here we have 2. And now here we have 6. Because here we have 6, then we can easily increase up to 3. And then you have the smiley showing that your equation is balanced. Now we can hide out this to show the simulation, the representation. We can hide now we can show the boxes, and we show the box for the products. You can see we have 1 nitrogen molecule which has 2 atoms and 3 hydrogen molecules combining to give 2 ammonia molecules, right? Now let's use the tools. Balance, what does it show on this side? Remember, for nitrogen, this is the left-hand side and this is the right-hand side. For hydrogen, this is the left-hand side and the right-hand side. And you can see that we have 2 and 2 on both sides. Here we have 6 and 6 on both sides. Now, what happens when your equation is not balanced? Let me reduce this to 2. See, for nitrogen, it's balanced 2 and 2 on both sides, but for hydrogen, and see here we have 4, and here we have 4 and 6. 4 and 6. So it's not balanced. So we have to increase it by 1, and we get our equation balanced. The other tool you can use is this one. You can see we have nitrogen, it's 2, and hydrogen is 6. So we need more hydrogen atoms to combine with 2 nitrogen atoms. So the combining capacity of nitrogen is greater than that of hydrogen. And that is equal to the 2 nitrogen and the 6 hydrogen. So those are the tools. Now let's reset, and we go to the separation of water. What do you think will happen? Or what do we have to, the numbers we have to put here? Here we have 2 hydrogen atoms. Let's start with 1 on both sides. We start with 1 on both sides, and we see what happens. Now we count. We have 2 hydrogen atoms and 2 hydrogen atoms, and here we have 2 oxygen atoms. So here it's a problem. We have 1 oxygen atom in the left-hand side and 2 oxygen atoms on the right-hand side. So here we have to increase by 2. Here we have to increase to 2. Now we have 4 hydrogen atoms and 2 oxygen atoms. Here we have 2 oxygen atoms, but here we still have 2 hydrogen atoms. So we increase to 2. And the smiley again appears. You have to show that we have correctly balanced our equation. To show that we have correctly balanced our equation. Using the tools, we get the same thing as what we have got with the making ammonia. And here we have hydrogen. On both sides, we have 4 and 4, 4 and 4. So we have 4, 4. And here we have, for oxygen, we have 2 and 2. 2 and 2, okay? And here in the box, you can see we have 2 molecules of the reactants, 2 moles of the reactants. And here we have 2 moles or 2 molecules of the hydrogen molecule and 1 molecule of oxygen or 1 mole of oxygen. I hope you remember the difference between molecule and mole. And here, because we are just balancing, we can use that. But generally, in chemistry, because it's not very easy to isolate a single molecule, then it's better to use moles. Moles which are a given packet of molecules equal to 6.022 times 10 power 23 molecules. And here we have another chemical reaction. As I said, we start with 1, 1, 1, and 1. And now you can see the equation is not balanced. We have carbon, we have hydrogen, we have oxygen. For the oxygen atoms on the reactant side, we have 2, and here we have 3, the product side. So it's not balanced. For the carbon atoms, it's balanced. You can see it from here. 1 carbon, 1 carbon. Here we have 4 hydrogen, I have 2 hydrogen. You can see it from here. 4 hydrogen and 2 hydrogen. So we have to balance it. How do we get it balanced? Let's start with the carbon. The carbon is already balanced. And now let's go to hydrogen. Here we have 4 and here we have 2. Let's increase to 2. For the hydrogen atoms, now it's balanced. We have 4 left-hand side, reactant side, and 4 the product side. And for the hydrogen, here we have 2, but here we have 4. So we increase to 2, and our equation is balanced. Well balanced. Okay? I hope that you have understood how we use the simulation to balance the chemical equations. Now here is the game. You have to choose the level you want. I will show you an example. You choose the level, and then with this example, or the exercise you have here, you have to make it balanced. So I will balance 1 for you to let you know how it looks like when you get the right answer. So here we have carbon and sulfur. Start with 1, 1, and 1. But here we have 2 sulfur. So here we use 2. And then we click on check. The answer is right. So you can go to the next. And when the answer is not right, then it will be indicated here on the screen that your answer is not right, and you will have to retry. Okay? And you can also start again the exercise or the game. So that is all I had for you today. Now, if you allow me, let's jump to the quiz. Here we have the quiz code. If you are ready, you can immediately take the quiz. If you don't feel confident enough to take the quiz, you can replay the video to be already. So the quiz code is VID 001013. And the steps we have to go to the website or panda.xyz. You click on login, it's here. The login button, it's here. And the following, this window will appear. And as the window appears, you click on Take Quiz. And when you click on Take Quiz, this is what will appear on your screen. And then you type here the quiz code. Remember, it's VID 001013. You type it in this box and then you take the quiz. I hope you enjoyed. See you next time.